Hi, welcome back. So, this chapter we're going to talk about Simplex method. So, in last session, we introduced how to the linear programming problem, how to find the maximums about the profit. So, we introduced two things. One is the maximize function. We also call it object function. Something that we're trying to maximize with. And the other two is the constraints function. So what is constraints function? Remember? So last time we're trying to find the visible vision, which is this shady area is our visible vision. It's bounded by two linear functions. These two linear functions are called constraint functions. So, graphic is easier if we only have a variable of 2 because we only have x and y axis. But what if we have 3 or more variables? So today, the method that we introduce, Simplex method, is going to solve this problem. So how do we do that? Here is an example. We have a maximize function, p equals to 5x plus 4y, and two constraint function, 3x plus 5y less than or equals to 78, 4x plus y less than or equals to 36. Step 1. We want to convert inequality into a equation. By insert slack variable. Okay, so which two inequality we have? We have the constraint function, which is 3x plus 5y. Now I want to insert a slack variable. That could be any variable, a, b, c, d, e, f, g, u, w, s, y, z. Those are okay as long as they're not repeated. So since now we have x, y, and p, it's given. So we can use anything but s, y, and p. So now, after you insert the slack variable u, this equation becomes 78. For the second inequality, we do the same thing. 4x plus y plus w equals to 36. Okay. And then we still need to do something about the object function. So for the object function, we want every variables on the left side and the constant on the right side. So that we have a p equals to 5x plus 4y, right? We want to move 5x and 4y to the left. So I have negative 5x minus 4y plus p equals to 0. The reason we do that because we want to construct the initial tableau. So for the initial tableau, it's going to look like that. The variable on the left and then constant on the right. So the variable, how many variables we have? We have x, y, u, w, and p. So now we insert all the constants into that tableau. So for the first function, 1, 2, 3. For the first function, we have what? 3, 5, u, we have a u. So the coefficient of u is equal to what? 1. So w and p is equal to 0 because they don't have it in the first equation. constant equal to 78. For the second one, we have 4y u equals to 0 because there's no u, but we have 1 w, so w equals to 1, and p also equals to 0. Constant equals to 36. For the last profit function, we have -5, -4, 0, 0, and 1, constant equals to 0. Alright, so after that, our step 3 is to find the pivot column. Find we need to find the smallest one. In this case, what will be the smallest one? Will be 9, right? So this is our pivot row. Sorry. Let me erase this. This is from pivot row. Okay, so what will be the intersection? The intersection would be the 4, right? Here we have the 4 as the intercept. So this intersecting element, which is 4, this is going to be our pivot point. So the fifth step is we want to convert our pivot point into 1. So now let's take a look at here. Our pivot point is 4. How can we convert 4 into 1? So you want to 4 divided by 4 so that you will get 1, correct? So now let's take a look. I want the second row, all the rows divided by 4. So that I can convert the 4 into 1. So now let's construct a new one. We have what? S, Y, U, W, P, and the constant. The first row remain the same. Nothing is going to change. Still 3, 5, 1, 0, 0, 78. So now let's look at the second one. All the second row divided by 4. So I have, oh, I'm sorry. This one shouldn't be y. This would be what? 4x plus y. So this should be 1. So all the second row divided by 4. So I have x equals to 4 divided by 4 equals to 1. And then y, 1, the coefficient of y, 1, divided by 4 is equals to 1/4. And then 0 divided by 4 equals to 0. And then the next one is 1 divided by 4 is 1/4. And then p divided by p equals to 0. 0 divided by 4, which is 0. And then I have 36 divided by 4 equals to 9. Okay, and then the bottom row remain the same because we haven't do anything yet. Okay, so after we've done this, our pivot element remain the same. So our pivot element still be here. So the next step is we want to get 0 of these two, the above and below it. So how do we do this? So this is our second row, is our pivot row right now because the row contains the pivot element. So how can we make the element, which is 3, to become 0 by doing some row operation. So we can use the first row minus 3 times of the second row. This is really similar to when you're trying to solve a system of linear equation, you use elimination method. And then for the second one, for the third one, how do you eliminate -5 to become 0? We can use the third row minus or plus 5 times the second row. Remember, because the second row is the pivot row, so we're always trying to plus or minus the pivot row by times some numbers. So I'm going to show you how to do the first one, and the other one I will going to skip. So with x, y, u, w, p. So now the first row is become what? R1 minus 3 times R2. So look, R1 minus 3 times R2. So I have 3 minus 3 times 1. That give me 0, which is what we want to get. And then the second one, 5 minus 3 times R2, which is 3 times 1/4. So I have 17/4. And then for this element, I have a 1 minus 3 times 0. That gives you 1. And for W, I have 0 minus 3 times 1/4. So I have a -3/4. And then for P, I have 0 minus 3 times 0. So I have 0. The constant, I have 78 minus 3 times 9, which is equals to 51. Okay, the second pivot row remain the same. I have a 1, 1/4, 0, 1/4, 0, 9. Okay, so the bottom row, I have -5 minus -5 plus 5 times the second row. That's the row operation that we want for the third row. So I have 5 times the first row, which is -5 plus 5 times 1 gives me 0. So similarly, we do the rest of the row operation. We have -11/4, 0, 5/4, 1, and 14/5. Okay, so after that, we got our new tableau. So what to do next is we repeat what we did earlier, now finding our new pivot element. So now look at the bottom row. Which one has the most negative elements? So now, which one is the most negative element in the bottom row? It's going to be -11/4, right? So here we find our pivot column, and now we still need to find our pivot row by using the test ratio. So what is the test ratio? Remember, it's going to be the constant divided by the element in the pivot column. So divided by 11/4. Oh, sorry, it's 17/4. So this is equivalent to 51 times 4/17. This is equals to 12. And then similarly, we use 9 divided by 1/4, which is equivalent to multiply 36. So this is equal to multiply by 4, so it gives you 36. So which one is the smallest? Will be 12. So here is going to be our pivot column. No, I'm sorry, pivot row. So which one is our pivot element? It's the intersection, which is this one. Okay, so after we have the pivot element, what do? We want to convert this to become 1. So how do we do this? We want to multiply How can we convert 17 over 4 to 1? We multiply by 4 over 17. Good. So now what we want is we want the first row multiply 4 over 17. So now here we got our new tableau. So this requires quite a little bit of a calculation. So please do it by yourself. Here is the answer. I already did it on my draft paper. So I have 0, 1, 4 over 17, and the negative 3 over 17, 0, and 12. Okay, and then I write down the other two rows. 1, 1 fourth, 0, 1 fourth, 0, 9, 0, negative 11, 4. Okay, so remember, this is our pivot element, and then we want these two to become 0 by doing some row operation, like how we did for the elimination. So how can I eliminate 1 fourth? Well, we want the second row subtract 1 fourth the first row. And then how can I make the third row to become 0? Well, we can use the third row to plus, since this is negative. We want to pass 4 over 11 times the first row. So after the calculation, we will attain this new tableau. So after we attend this tableau, as you can see, there is some elements contains 1. And then when do we know to stop? Should we repeat what we did? No, we can stop right here. As long as the bottom row doesn't contain any negative elements. So what's the last step? The last step is we convert the pivot onto 1. So now we can stop right here because we complete this tableau. Because we have no more negative number on the bottom row. Okay, and then we read out the answer by the row with 1. What's that mean? So now what is the 1? The 1 we have in here, here, and here, right? These represent our variable. So that means our y equals to, this is the constant of y equals to 12. And then we have our x equals to 6. And then our p equals to 78. In that case, that means the maximum is going to be 78 when x equals to 6 and y equals to 12. That's the simplest method. Okay, I'm going to show you another example with 3 variables. So here we have the maximize function we have our maximize function p equals to 5x plus 7y plus 9z. And this is subject to our constraint function. So here is our maximized linear programming problem that we are trying to solve. So what's the first step? The first step is we want to insert some slack variables. So, and turn this into a equation. I have x plus 4y plus 2z plus any number. I can be a, I can be b. Let's say a equals to 8. And then the second function, I have 3x plus 5y plus z plus b equals to 6. And then we still need to convert the p function, the maximize function, and we want the constant on the right side and the variables on the left side. Okay, so now we can construct our initial tableau. X, Y, Z, A, B, P, and constant. So 1, 4, 2, 1, 0, 0, 8. For the first function. The second function, the coefficient would be 3, 5, 1, 0, 1, 0, 6. So the bottom function is going to be our maximize function. I have -5, -7, -9, 0, 0, 1, and 0. Okay. So now finding our pivot column by finding the most negative number, which is going to be here, -9. And now we need to find the test ratio. So the test ratio, we got what? 8 divided by 2 equals to 4. 6 divided by 1 equals to 6. So the smallest test ratio would be the first row, right? So here is our pivot row, and then the intercept one, 2, is our pivot element. We want to convert our pivot element equals 1. What can we do is we want the first row times 1/2. So now we have our nude element. I'm sorry, we got our nude pivot table. Which is 1/2, 2, 1, 1/2, 0, 0, 4. So the second two will remain the same. We haven't done anything yet. So 3, 5, 1. Okay, so again, this is our pivot element. We want to convert. We want the element below or above the pivot element to become 0 by doing some row operation. So for the second row, this is relatively easy because we can use the second row to subtract the first row. And then for the third row, the second row subtract the first row. And then we want the third row to add 9 times the first row. Okay, so after this operation, we got this tableau. Oops, not this one, I'm sorry. Okay, and then since there's still some negative element in the bottom row, that means this is not done. We need to repeat what we've done by finding the pivot element. So the pivot column would be the first one, right? And now we need to have our test ratio. We use 4 divided by 1/2, which is equivalent to multiply 2, which is 8. And then the second one, we have 2 divided by 5/2, which is equivalent to multiply 2/5. So this is equals to 4/5. So which one is smaller? The second one is smaller. So this is going to be our pivot row. So the pivot column and the intersection between pivot column and pivot row, we found our pivot element. We want the second row to multiply 2/5 so that our pivot element will become 1. So here is our new pivot table. So everything else becomes the same. So this has become 0, 6/5, 0, negative 1/5, 2/5, 0, and 2 times, 4/5, sorry. Okay, so the bottom one remained the same. Okay. Oh, sorry, this is equal to 1, not 0. Keep writing this wrong. Okay, so keep that in mind. This is our pivot element. We want the element above or below equals to 0 by doing some row operation. So that means we want the first row minus 1/2 of the second row. And then we want the third row plus 1/2 of the second row. We want the third row plus 1/2 of the second row. Okay, so we will get our new tablet, which is oops. So we have 0, 7/5, second row is 1, 6/5, 0, -1/5, -1/5, 2, oops, 2/5, 0, 4/5. I'm going to pause the video and write down all of the calculations. So here's our final calculation. So are we done? We're done, right? Because the last row doesn't contain any negative number. So now what will be our answer? Our answer is when the elements equals to 1. So we have 1 in here, 1 in here, and another 1 in here. That means what? That means when z equals to 18/5 and our x equals to 4/5, p will equals to 185 over 5th. Oh, 182, sorry. That's the, I write this wrong. This should be 182. Okay. So this is going to be our maximum when x equals to 4/5, z equals to 18/5, and p, the maximum, p equals to 182 divided by 5. So what about y? How do we determine y? So in this case, our y, they are not equal to 1. So that means we will let y equals to 0. Okay. So that's it for Simplex method. Let me know if you have other questions.